Hello, everyone, and welcome to today's Explainer. So if you've been following along in our software engineering journey, you already know that Agile methods were originally designed for small, co-located teams. People who could literally just turn around and chat across a single desk. And for those small teams, Agile has been an absolute game changer, delivering working software at lightning speed. But here is the core conflict we're tackling today. Massive corporations and government departments look at that amazing success and say, hey, we want that speed too. But when they actually try to apply Agile to complex, multi-million-dollar enterprise systems, they usually hit a brick wall. Today, we're going to unpack exactly why that happens and, more importantly, how the software industry solves it.
Okay, let's take a quick look at our agenda for this explainer. We'll be moving through 1. The challenge of scaling, 2. Friction points, 3. Mixing methods, 4. Building large Agile systems, 5. Overcoming culture clash, and finally, 6. An exam focus. Let's jump right in.
Right, part 1, the challenge of scaling. To understand how to apply Agile to massive projects, we first have to recognize that scaling Agile isn't just one problem. It's actually two distinct challenges happening at the exact same time. Let's define these terms carefully. First, we have scaling up. This is the technical challenge of using Agile methods to build massive, complex software systems that are simply way too big for a single small team. You need multiple teams, and coordinating them smoothly is incredibly tough. Second, we have scaling out. This is the human and organizational challenge. It involves introducing Agile practices across a huge corporation that has years, maybe even decades of experience using traditional, rigid, plan-driven approaches. And the reality of modern software engineering, large contracts usually force these organizations to tackle both scaling up and scaling out simultaneously. It's a massive undertaking.
Moving on to Section 2, friction points, contracts, and maintenance. Before we can start fixing the issues of scaling Agile, we really need to understand why pure Agile methodologies break down in the traditional corporate world.
There are three major friction points we see constantly. First up, legal contracts. Traditional corporate environments love fixed-price contracts based on a very rigid set of upfront requirements. But Agile assumes requirements are going to change constantly. So it's nearly impossible to write a traditional fixed-price contract for an Agile project without someone getting upset. Second, maintenance. Agile teams actively dislike heavy documentation, right? They'd rather focus on just writing working code. But think about what happens when that original Agile team inevitably leaves the project. A new maintenance team comes in, and they have absolutely zero formal documentation to help them figure out how the code actually works. It's a nightmare for them. Finally, Agile thrives with small, co-located teams, but massive global corporations almost always rely on distributed development teams spread across entirely different time zones.
Which brings us to Section 3, the compromise, mixing methods. Since legal contracts clash and maintenance teams are starved of documentation, companies have to compromise by mixing Agile with traditional, plan-driven methods.
This comparison brilliantly illustrates the balance that has to be struck. On one side, you have pure Agile. It's informal, it embraces rapid change, and it works flawlessly for small teams. On the other side, you've got the plan-driven approach, heavily reliant on documentation, stable architecture, and upfront planning. Listen, when you're building a massive system with hundreds of developers, you absolutely need the stable architectural framework that plan-driven methods provide. You simply cannot build a massive enterprise system on the fly.
It's a really common misconception that pure Agile works for absolutely everything. It doesn't. Here are the specific factors that will absolutely force your development team to lean heavily back toward plan-driven methods. If the system is incredibly large, you need upfront architectural planning. If there are strict external regulations, like in aviation or medical software, you're legally required to produce heavy design documentation. If the system is expected to have a long lifetime, documentation is non-negotiable for future maintainers. If your teams are distributed globally, you need detailed specs to communicate effectively. And interestingly, if your team has a lot of junior or low-skilled programmers, a plan-driven approach gives them detailed step-by-step design documents to translate into code, whereas Agile requires high-level problem-solving and proactive self-organization.
Section 4, building large Agile systems. Now that we understand why compromise is necessary, let's shift our focus to how we actually structure the technical frameworks to build these massive software systems. I want you to pause and think about this for a second before we introduce the next concept. In the real world, you are almost never building a massive system from a completely blank slate. So, what happens when your brand new, rapidly changing Agile software has to interact with a rigid, decades-old legacy system?
This brings us to a vital term you absolutely must know: brownfield development. Brownfield development is defined as the process of building and managing software systems in an environment where they are dependent on and must interact with older, existing legacy systems. So why does this matter for Agile? Well, it prevents pure incremental development. You can't just rapidly change your new code if doing so breaks a massive legacy banking system. Every change requires intense negotiation with the managers of those older systems, forcing a much slower, planned approach.
The sheer complexity of large projects is mind-boggling. Beyond just brownfield development, large systems are often systems of systems, meaning entirely different companies build independent parts. You also have incredibly diverse stakeholders, from end users to corporate executives and government regulators. That makes it impossible to get everyone in a single room for a quick Agile stand-up meeting. Plus, these systems have prolonged procurement times. Over a multi-year project, the developers who started the work will very likely leave for other jobs, meaning the informal knowledge Agile relies on so heavily is completely lost without formal documentation.
To manage all of this chaos, industry leaders have created scaling frameworks. A great example is IBM's Agility at Scale model, which is structured in concentric circles. In the very center, you have core Agile development, your standard, self-organizing Scrum teams just focusing on construction. But as you move outward to the next layer, you hit disciplined Agile delivery, where risk and value-driven life cycles are added. Finally, in the outermost ring, you have Agility at Scale. This is where you adapt your entire process to handle geographic distribution, regulatory compliance, and massive organizational complexity, effectively folding plan-driven disciplines right back into the Agile mix.
So, practically speaking, how do we scale up a framework like Scrum? We do it in 4 specific steps. Step 1 is role replication. Every single individual team gets its own product owner and Scrum Master, and you might even have a chief product owner overseeing everyone. Step 2, product architects. Each team nominates an architect, and they all collaborate to design the overarching, stable architecture. Step 3 is aligned release dates. You make sure every independent team synchronizes their releases so a complete system can be integrated and tested together. And finally, Step 4 is the Scrum of Scrums. Let's formally define this one, as it's absolutely foundational. The Scrum of Scrums is a daily meeting where representatives, usually the Scrum Masters, from multiple smaller Scrum teams, meet to discuss overall progress and identify cross-team problems. Instead of top-down management just dictating what to do, this clever setup allows multiple distributed teams to stay aligned, surface integration issues early, and maintain that self-organizing spirit of Agile, just at a much larger scale.
All right, Section 5, Overcoming Agile Culture Clash. We've covered the technical frameworks to scale up, but let's transition back to the human element. Introducing Agile to a traditional corporation often triggers a massive culture clash. Why do large companies culturally resist Agile so hard? Well, first, traditional project managers fear the risk. They're used to detailed Gantt charts and feel that self-organizing teams strip away their control. Second, large organizations rely on strict, bureaucratic quality procedures that conflict directly with Agile's rapid, informal testing. Third, Agile relies on constant refactoring, developers tweaking code whenever they find a better way. But corporate formal change management standards dictate that every single change must be approved by a committee first. Finally, as we mentioned earlier, Agile assumes a high baseline of programmer skill, which clashes with the huge range of abilities found in massive IT departments. Changing this entrenched culture takes years and requires deeply enthusiastic evangelists inside the company. Section 6, Chapter 3, Comprehensive Summary. We are now wrapping up this topic, so let's move into a comprehensive recap to solidify everything we've covered regarding Agile software development.
Over this entire chapter, we first learned about the Agile Manifesto, which fundamentally shifted the focus away from heavy documentation and rigid plans and toward producing working code and responding to change. We explored Extreme Programming, or XP, which introduced brilliant practices like writing requirements as user stories and test-first development. We then looked closely at Scrum, the management framework that organizes work into short, time-boxed sprints drawn from a prioritized backlog. And finally today, we explored the realities of scaling, how those pure Agile methods absolutely have to be mixed with plan-driven documentation and architecture to survive in the complex, brownfield environments of massive enterprise development.
Exam focus and conclusion. The crucial point here is making sure you can demonstrate all this knowledge academically. Let's transition into our laser-focused exam preparation segment.
I highly recommend that you memorize these specific terms for your tests. You need to know these exact definitions. First, brownfield development is building and managing systems in an environment where they are dependent on and must interact with older, existing legacy systems. Second, the Scrum of Scrums is the daily meeting where representatives from multiple smaller Scrum teams meet to discuss overall progress and identify cross-team problems. Lock those in. Having these exact definitions ready will serve you very well.
Furthermore, you must be able to list the 3 critical reasons why Agile methods clash with traditional corporate environments. 1. Contracts. The corporate need for fixed price agreements heavily clashes with Agile's constantly changing requirements. 2. Maintenance. Agile's lack of documentation makes it incredibly difficult for separate, long-term maintenance teams to support the software down the line. And 3. Culture. Self-organizing teams clash heavily with traditional project managers, strict quality standards, and formal change management bureaucracies.
To conclude, congratulations on mastering Agile software development. You now understand not just the textbook theory, but the messy, complex reality of applying these methods in the enterprise world. As we prepare to move on to requirements engineering in our next module, I want to leave you with this provocative thought to ponder. As technology improves and generations shift, will traditional engineering cultures eventually adapt entirely to pure Agile? Or are plan-driven methods absolutely permanent fixtures necessary for the survival of massive systems? Think about it. Thanks so much for joining me on this explainer, and I will see you in the next one.